friends. So today our topic is topological sorting using adjacency matrix. So first of all, this is one type of graph traversal technique. We have to traverse the all vertices of the graph and sort them using adjacency matrix. Okay. So there is given a directed acyclic graph with V vertices and E edges. We have to sort them using topological sort, V number of vertices and E number of edges. Okay. Now in topological sort, node U will always appear before node V if there is a directed edge between node U and node V. That means node U is always before node V. Why? We know if there is a direction from node U to node V, then we have to write as node U to V. We know na. From 2 to 3, if there is a direction from 5 to 2, then we write 5, then 2. So if there is a U to V, then we have to write U before V. Okay. Now let's understand what is topological sort using a graph. So here a graph is given as an example. The number of vertices in the graph is 6, 0, 1, 2, 3, 4, 5. Number of vertices is 6, 0 to 5. First of all, we have to find a adjacency matrix of this graph. So find the adjacency matrix of the graph. So there we know that how to find the adjacency matrix. Let us find. From 0 there is no connection to 0. There is no direction in the 0th path. So from 0 all are 0. Now from 1 is there is no connection from 1 to any. There is connection from 3 to 1 and 4 to 1, but not connect any 1 to anything, any vertices. So 1 is also totally 0. Now coming to vertices 2, there is a connection 2 to 3. There is no connection, excluded that. So only 2, 3 is 1 and rest of all are 0. Then in the vertices 3 to 1 is connected. So we write 3 to 1, this one 3 to 1 is connected, is 1 and rest of all are 0. Now in vertices 4 only 4 to 0 and 4 to 1 is connected. So 4 to 0 is 1 and 4 to 1 is 1 and rest of all are 0. In vertices 5 to 0 and 5 to 2 is connected and rest of all are 0. So 5 to 0 and 5 to 1 is connected and rest of all are 0. So this is the adjacency matrix. Let us name this as A. Okay. So the adjacency matrix is given as this. Okay. I hope you understand. Now how to sort using topological sort. So to sort a graph using adjacency matrix for a topological sort, first we have to introduce a variable. Let's say the variable name is m. Okay. So first initialize m equals to 1. What is m? M is the counter, or m is the path, m is the number, m is the sequence number. Better to say m is the sequence number. Now we have to check or find out the column which is totally 0. So from this adjacency matrix, whole adjacency matrix, we have to find what? We have to find the column which is totally 0. So we have to find which is totally 0. We check that in this adjacency matrix, this column is totally 0. No, there is 1 and 1. This column is totally 0. No, there is 1 and 1 again. This is totally 0. 1 and no, there is 1 again. This is totally 0. No, this is 1. This column is totally 0. And again this column is totally 0. So we have to choose any of them, 4 or 5. Suppose I choose column number 5. So we check out of totally 0, so we can see that column 5 is totally 0. Column 5 is totally 0, so we have to discard. So we have to discard the column 5. So we have to discard the column 5. So we have to discard the column 5 just like that. Sorry, give me one second. So we have to discard the column 5. We have to omit the column 5 as well as the same row number. That means the same row. That means the 5 number row, because we have to discard the column 5. So there is column 5 and we have to discard the same 5th column, so that we have to discard the same 5th row. Okay. So we have to discard the same column 5 and we have to discard the same row 5. Then assign vertex 5 in M. So the M value is, now the M value is 5. So 5 number vertex is in, now the M is included in M. So M is now 1. So 5 is the first position holder. 5 is the first position holder in the sorting. Now we have to, now what is the algorithm says? Algorithm says that M equals to M plus plus. We have to increment the value of M. So M becomes 1 plus 1, M becomes 2. M becomes 2. So what is the remainder matrix? What is the remainder matrix? Give me one second. So we have to excluded this one and this column and this row. So this is the remainder matrix. Again we have to check what? We have to check which column is totally 0. Now we see that this column is not totally 0 because there is a 1. This is not totally 0 because there is 1. This column is also not totally 0 because there is 1. This column is totally 0 because there is no 1. So column number 4, now column number 4 is discarded totally. Column number 4 is discarded totally. So column number 4 is 0, so we have to discard column 4 and as well as row 4. So we have to check the column and discard the column also and row also. So assign vertex 4, column number 4 means it represents the vertex 4 na. So assign vertex 4 in the M value. Vertex 4 is the M value is 2. So vertex 4 is the second position holder in the sorted sequence. Okay. Now updated the value of M. M becomes 2 plus 1. M becomes 3. Then the updated matrix is just like that, 0 1 2 3 and 0 1 2 3. So 0 1 2 3 and 0 1 2 3 and the values are 0 0 0. Again we have to check which column is totally 0. This column is totally 0. This column is totally 0. Yeah, this column is totally 0. Column number 0 is totally 0. So we have to choose column number 0. We have now check column number 1. Column number 1 is totally 0. No. Column number 2 is totally 0. Yeah, column number 2 is totally 0. Column number 3 is totally 0. No, column number 3 is not totally 0 because there is a 1 na. So we have to choose any of them. We have to choose column number 0 or column number 2, any of them. Suppose I choose column number 2 as the next one. So what we did, we have to omit column number 2 as well as we have to omit what row? Same row, row number 2, same row value, same column value and same row value. So the matrix is look like that one, 0 1 3 0 1 3. So we see that column number 2 is totally 0, so we have to omit column 2 and row 2. Here is written. So assign M value to 2. M is now M is 3. So column number 2 is in the third position. Okay, column number 2 is in the third position. Now M value is updated, M equals to M plus plus and M value is now, current M value is 4 and our matrix is, current matrix is 0 1 3 0 1 3. So the updated matrix is just like 0 1 3 and 0 1 3. Now we have to choose any of them. column. Now we have to check column 0 is 0. Yeah, column 0 is 0. Column 1 is 0. No, column 1 is not 0. There is a 1. Column 3 is 0. Yeah, column 3 is 0. So I have to discard any of column 0 or column 3. So we have to choose any of them if there is column 0 or column 3. So let us choose column 3. We have to choose column 0 also, but let us choose column 3. Okay, so we have to omit what? We have to omit column 3 and also the same row number. Same row number means column 2, column 3, sorry. So here is written that as we see column 3 number is totally 0, so we have to omit column 3 and row 3. Assign m value to column 3. 3 is the fourth position in the sorted because m value is 4. So 3 is appointed as fourth position in the shortest sequence. Now the updated m value is m equals to m plus plus, m equals to previous m value is 4 and now updated is 4 plus 1 equals to 5. Okay. Now the updated matrix. What is the updated matrix now? The updated matrix is 0, 1 and 0, 1. 0, 1 and 0, 1. So both are 0. So we have to discard any of them. So as we move from left to right, previous one, so we choose 1 to be omitted. You may choose 0 also, but this is no first and rule that you have to choose only 1. You have to choose 0 also, but we choose as left as our precedence order. Okay, higher precedence. So we have to omit 1. Okay, now what we see that one number column is totally 0, so we have to omit column 1 as well as column 1 as well as row 1. Now the updated value is previous value is 4, previous value is 5, and now the 5 plus 1 is 6. The current m value is 6 and the updated matrix is only 0 is left, so we have to discard this one and appointed 0th vertex to the m value. So 0th vertex is in, sorry, this is not 0, is in, so 0 is appointed in the 6th position. So as we know that m value helps us to know about the position of the sorted sequence. So according to the m value we have to sort the vertices. So first m value we get 5 equals to 1, we get 5 equals to 1, then we get 4 equals to 2, then we get 2 equals to 3, m value 3 equals to 2. So the sorted sequence is 5 4 2 3 1 0. Hope you understand.